Hey everyone, in this video we'll take a look at the details of filtering. We'll also look at some tricks to make debugging your code move a little faster. So filtering is just a way of taking a large data set that includes many different types of information and reducing it to only include certain types of information that we're interested in. A number of apps we're developing are helping users make decisions by filtering a very large data set by the user selector criteria down to a smaller data set that is more easily understood by humans. So the example that we're looking at here is the dogs table. And what we see is that there's a lot of different information going on here. There's maximum lifespan, minimum height, maximum height. There's the name of the dog, the breed. There's the breed group, what they're bred for. There's a lot of different stuff here, and we might not be interested in all of this depending upon what we want to do. Sometimes we want a filtering algorithm, and that's just a sequence of steps that gets us from point A to point B. Nice. So sometimes we want a filtering algorithm that can produce a single item at the end of a process, and sometimes we want an assortment of items that we can pick from based on harder to quantify criteria like personal taste. So for this table up here, maybe we see that there are certain breed groups. Here's a working example. Working, and if we go down here, we see that this is max weight. So this is 120, 115, and 100. Maybe we want to be able to select a working dog that is no more than 100 pounds, which would leave these two off of the filter list. So we would have to do two stages of filtering. We would have to get rid of everything but the working dogs. We would want just a list of working dogs, and then we would have to sort that according to weight. In our class, we've been using a data structure called a list to achieve our filtering goals. We'll traverse the list using either while loops or for loops and compare individual items in the list with our criteria and keep track of the items that match our criteria. And we've been looking at different tables. It's important to note that there are two perspectives on what's happening here, and this is the direction that we're going in. There is a human perspective of looking at the table, right? That's where we're looking at the actual entries. When I look at this, aside from the table, this index value tells me nothing, right? I have to see this other information for it to make any sense. I see loyal, independent, intelligent, and brave. I see sheep guarding. I see things that I can understand as a human. And we're looking at actual entries like either the title of a movie, the breed of a dog, or the package style that noodles can be purchased in. Then there is the computer's perspective of looking at the table. And this is the way it's actually organized in the table that we're looking at. Computers do this by using the location where the entries are stored. They don't care what the values are inside of these boxes. They just know how to get to a certain box. So if you have a breed group and an index, it knows that it can look down this column and this row, and it finds the intersection, and that's the value that you're looking for. So this exists for us already. And different attributes associated with a common selection are stored in the same row of the table. So everything for ID2 here is related to this Afghan hound, and it's just a bunch of information. So what's common here is this index value, this ID, and that's how the computer goes about finding these things. While there are different ways of keeping track, most of our current endeavors will have us doing multiple stages of filtering, just as we had that example. Because of this, the easiest way to keep track of items that match our criteria is to create a list of indices into the original data table that point to those matching items. So before going any further, we need to define a new term that's going to help us describe relationships between indices and the entries they reference. That term is map. What we're looking at here is a map. Maps have direction. There is There's a key, as they call it, which in this case is the index, and then there are particular values that we can look at inside of this. The important thing about a map is that it has direction. The ID points to something else. It takes a unique identifier, and sometimes there's more than one value, right? Like we're seeing here. So index 1 has a name and has a breed group. When we are looking for something in a map, the computer searches for the key. Well, that's for the computer itself. That's this index value here. And then the values are everything that that particular key references. There are two important considerations at this point that need to be addressed. The first is that a mapping exists from indexes to entries, right? That's what we're given here. One provides all of this business, and that's the way the data table is structured. If you have an index number, you can easily locate the row because there's a unique index number. All of these numbers are different. That's helpful for the computer because that's the perspective that it uses to access the table. It's not so helpful for humans because we see a particular entry as a table value. We want to know the index or key that points to that value. So basically we want to have a breed group and we want to point to something else. We want to use this value as the key and maybe something else. And actually it turns out that what we're going to be interested in is the index because that provides us the greatest flexibility. But that doesn't exist. So we're going to have to build one. We are going to build a map that links a particular type in this, and you'll notice that sometimes if we base it on breed group, that there are going to be more than one index value that that key points to. So we'll do a more detailed example of this.